Product rule and quotient rule. The product rule and quotient rule are two important rules to know in calculus. Now, the product rule says if you're multiplying two things together and you want to take the derivative, you take the derivative of the first one times the second one, plus the first one times the derivative of the second one. The quotient rule, so if you're dividing two things and you want to take your derivative, the quotient rule says take the derivative of the top, multiply it by the bottom. Then just subtract what the top was originally times the derivative of the bottom, all divided by the bottom squared. You're going to need to make sure you know both of those rules. We're going to go ahead and work these out. The first one here is a product, two things multiplied together, so we'll use the product rule. It says take the derivative of the first. The first is your what's in the first parentheses, and that's just a 4x. Then it says multiply it by the second, so we don't do anything to the second. Then it says go plus. And you keep the first the same, but then you got to multiply it by the derivative of the second. Then all we have to do is just to do a little bit of simplification. Go ahead and distribute through. And collect your like terms. The second one is also a product rule. So if needed, pause the video while you work it out. So we take the derivative of the first times the second, plus, keep the first the same, multiply it by the derivative of the second. Eliminate your parentheses, collect your like terms, and that's all we're looking for. Here we're dealing with a quotient because we're dealing with things that are divided. So we're obviously going to have to use your quotient rule. So it says we need to take the derivative of the top. The derivative of the top is just a 2x. Multiply it by the bottom. Minus. Then we got to take the top, which is your x squared minus 4. Multiply it by the derivative of the bottom. That's where this 2x comes from. Now, we got to put that over your denominator, but all squared. Now, for simplicity, since we have a common factor of a 2x on top, we could actually go ahead and pull that 2x out. Pull 2x out from the first parenthesis, leaves us just with an x squared plus 4. Pull a 2x out of the second parenthesis, and remember to distribute through the negative. And that's where this right here comes from. Still over the bottom squared. Now the parentheses just simplifies down to 8 on top times your 2x in front, so you get a 16x over your denominator squared. Looking at this one here, it looks a little scary to some of you. But all we're going to do is simplify before we attempt to take our derivative. When you look at your original problem, you have fractions within a fraction. So we're going to find our common denominator, which happens to be just your x squared plus 1. We're going to take our original problem right here, which we have over here, just multiply it by that special form of 1, which is from your LCD. Then you're going to have to take and distribute that through. You're going to take your 2x plus 1, apply it to your 3, or x cubed, and then you take your 2x plus 1 and apply it to your 1 over x. When you take that 2x plus 1 to your x cubed, you get this right here. Take your 2x plus 1 times 1 over 2x plus 1. They cancel out, leaving you with just a minus 1. Then you got to distribute through in the bottom. You're going to take your 2x plus 1 to your 4x. Take your 2x plus 1 to your 1 over 2x plus 1, and that cancels out, leaving you with a 1. Distribute through to get rid of the parentheses on the top and the bottom. Now that it is simplified, then you'll want to go ahead and do your quotient rule. Trying to do your quotient rule before would also mean you'd have to be doing the chain rule, and at this point you don't know about the chain rule. So you need to simplify it first. So your quotient rule says derivative of the top times the bottom minus the top times the derivative of the bottom over the denominator squared. Then it's just a matter of simplifying the top. We're not going to do anything to the bottom. We'll just leave the bottom alone. But on top, you're going to have to eliminate your parentheses by multiplying through. And you get a big, kind of ugly looking mess. After you do that, here you're going to have to distribute your negative through to each one of these. And then just collect your like terms. And so that's how we get it simplified down. Here we have a product. You have two things multiplied together. So you're going to have to do the product rule. Derivative of the first part. The first part's your 3x squared, so your derivative, you put your 2 down in front, decrease your exponent by 1, you get a 6x. So that's the derivative of the first times the second. Plus, keep the first the same. Multiply it by the derivative of the second. Then just go ahead and eliminate your parentheses, and you get this. Now, if you wanted, you could also pull out a common factor of a 3x, but you don't have to. But if you wanted to, you could pull that common factor 3x out, and you get this. Here's the derivatives of your trig functions. We looked at the derivatives of sine and cosine the other day. So here's the derivatives of tangent, which is secant squared, cotangent, which is negative secant squared, secant, which is secant times tangent, and cosecant, which is negative cosecant cotangent. You're going to just have to have your derivatives of your trig functions memorized. If you happen to memorize them before you do your homework will be going a lot faster. Then we're going to go ahead and take derivatives. We're going to take the derivatives for the second derivative, third derivative, and fourth derivative. Here's the notation at the top, indicates second derivative. Here's your indication here of your third derivatives. Anything beyond a third derivative, you're not going to use primes anymore. You're going to end up putting a parenthesis and a number for your derivative in there. So remember, when you're taking your derivative here, you'd want to go ahead and use an x to the negative 2. Then you just go ahead and do a simple product or power rule, putting your exponent down in front, decreasing your exponent by 1. The second part here, to do your second derivative, it's going to be easier to go from the first part. And you just keep doing that until you get down to your fourth derivative. There you have all your derivatives for your first 4.